So I guess on Friday we went and we did the first three examples of example number three. I just looked at my thing, and apparently my stuff did not fit. So FYI, this is part of this equation. So the highest power here is x minus 5, and this is part of this little piece right here. I didn't notice that when I made my copies. Okay, so but let's get started anyways. So we know that for D, the degree is odd. We know that the leading coefficient is negative. If I could erase that, negative. So that means we're going to have something that kind of looks like this at the end behaviors. So that means from the left side is going to positive infinity and the right side is going to negative infinity. Remember, it's really important. We don't really care what's going on in the middle. We want to know what's going on at the end at each one. Then we also know for E that my highest exponent is odd. So again, it's going to be an odd function or odd degree. We know that the leading coefficient is going to be also negative because this is negative. That means then, remember, the leading coefficient is the number in front of the highest exponent. And if you notice, DE is not in standard form. It is not in the right order in standard form. It is in standard form, but not in order from highest to biggest. So because, again, it's odd, that means my function, again, will look something like this. It's going negative. So this one also would be left side is positive, right side is negative. And then our last one, we have to figure out our degree. So this is 1, this is 2, this is 3. So the degree, again, is odd because it's 3. Okay, the leading coefficient in this case is positive. So that means we're going to have, again, this way, odd degree, but now it's going to go to the positive section. So that means we're going to have left side is going to go to negative infinity, right side is going to go to positive infinity. For this one, you're going to write your limit statement. So we already know that it has an even degree. Leading coefficient is negative. So that means it's going to look like this. So that means as the limit as x approaches negative infinity, which is the left side, my f of x, my y, is going to approach negative infinity. Also, as my limit approaches the positive side of x's, my f of x is also going to go to negative infinity because it's both going down. Okay, next one. So we know this is an odd degree and the leading coefficient is positive. So that means we're going to have something that looks like this. If it looks like that, we know that then the limit as x approaches negative infinity, the left side, f of x is also going to approach negative infinity. And as the limit of x approaches positive infinity, f of x is going to approach positive infinity. Okay. On these examples, I'm going to say I need you to go to, before you copy what I drew, I want you to go to decimals.com and graph it, and you sketch it and see if it kind of matches what I have. So when you graph it, or at least when I graphed it, my sketch kind of looks like this for this one. And that tells me as a limit as x approaches negative infinity, f of x is equal to positive infinity. And as the limit of x approaches positive infinity, f of x also approaches positive infinity. When I graphed the second one, b, I got a rational function, and it had like an asymptote at 2. This is a line that it cannot cross. So it should have, I think it was something that looked kind of like this. Okay, and that one is as the limit as x approaches negative infinity, it's going to 2. So this is something that we haven't really talked to about. as x approaches positive infinity, f of x is approaching 2. Also, it is approaching 2 because it literally, this one is getting closer and closer and closer to this asymptote right here, and this one's getting closer and closer and closer to that asymptote, which is getting closer and closer as we go along. So it's not going to infinity, it's actually getting closer and closer to that asymptote, which is 2. We'll talk about more of that later on this as we do rational functions next chapter. And then we have this function that looks like this. And that one is approaching 0, which is this line right here. Okay, so we have the limit as x approaches negative infinity, f of x is getting closer to 0. And the limit as x approaches positive infinity, f of x is getting to 0 again. Okay, from here, you need to work on the review worksheet that the sub will give you. I'll be here tomorrow, and we could go over any questions you will have. I will post the answer key for the review during 7th period.